Hi, Dr. Ang. I'm Xin Yang, and my teammate is Fang Xiao. We are Group 6 Nano Pencil. We will present our topic, nano titanium dioxide catalyst used in photocatalytic hydrogen production. And here is our content. And for the part of introduction, the gradually exhausted fossil energy and increasing environmental pollution caused by fossil energy compel people to look for new energy urgently. And hydrogen is an important clean energy source, which is expected to replace fossil fuels in the future. And now the mainstream to make hydrogen always caused by the coal gasification, and it may also consume a lot of fossil energy and money. It is also not environmental friendly. So what we try to change. And we know that the water contain hydrogen items. Two famous Japanese, Honda and Fukushima, put forward to use titanium dioxide photocatalytic to make hydrogen. And the titanium dioxide has following advantages, like here, shown here. And recently, Julie Jia and their teammates investigate the ternary nanosystem for water splitting and generated 20.7 more millimole hydrogen for 18 hours irradiation. And for the types of titanium dioxide, here are usually 3 types of it. And these types can also convert to each other by changing the temperature. And here shows the structure for titanium dioxide. And for the mechanism of photocatalytic formation of hydrogen from water, usually divide to 4 steps. The first step is photon absorption, and second is charge separation. The third is charge transfer, and the fourth one, the latest one, is redox reaction. And if we use the methanol as a sacrificial agent to make hydrogen, we can find that the methanol is a kind of electron donor to prevent the recombination of photo generated electrons and electron holes so as to improve the production of hydrogen. And the hydrogen meaning comes from the water and also the metal. Fang Xiao will do the next part too.
Okay, thanks, Xinyao. So now I will present the discussion. So firstly, as the lightest gas in the world, hydrogen is a key of the energy structure transition in today's society. Besides, among many hydrogen production methods nowadays, photocatalytic hydrogen production has great potential for low-cost, environment-friendly solar hydrogen production. The structure of nanostructure can the construction of the nanostructure can improve the photocatalytic properties by changing the size of the photocatalyst and the specific surface area. Nevertheless, it's a pity that most semiconductor materials cannot perform their role perfectly because of the low energy band gap and the relatively high recombination rate of the photogenerated electron and holes. And TiO2, titanium dioxide, is currently one of the most widely investigated semiconductors because of its non-toxic long-term stability and the relatively high photocatalytic performance. Next, two preparation methods for nano titanium dioxide were discussed. So firstly, for solvent thermal alkalisis method, generally the solvent thermal process is conducted at the high temperature and high pressure to dissolve the previous cut with alcohol. Next, TiO2 will be nucleated and crystallized with ethanol as template during the slow hydrolysis process. Next, for soldier method, it uses titanium oxides or as raw materials through hydrolysis and condensation to obtain salt, which will be further condensed to form a gel. This gel is dried and cleaned to synthesize TiO2 crystals. Okay, next, this table summarizes the two methods. We can say that the solvent thermal alkalized method has advantages of high crystallinity, disperity, good controllability, and safety. However, the high requirement of the equipment and high capital costs are disadvantages. While for soldier method, the TiO2 obtained show a uniform size distribution and few side reactions. However, the high raw material cost easily agglomerate of synthesized TiO2 particles are the disadvantages. So next, the four improving methods of photocatalytic are shown here to improve the TiO2 photocatalytic performance. Firstly is the metal ion doping method. What we use commonly materials are PT, AU, AG, and so forth. So you can promote the separation of photoelectron hole pair. Secondly, you expand the ultraviolet absorption region of TiO2 to the visible absorption region. Next, ion doping. Commonly, materials are sulfur or nitrogen, and so on. So it can reduce the band gap of titanium dioxide, expand the UV absorption region to the visible absorption region, and cause TiO2 lattice defects. Next, the composite semiconductors, the materials used are CDS or SNO2, so it can retard the recombination rate and improve the photocatalytic performance. And lastly, dye sensitization method. Common materials are phenol, chlorine, and so forth, so it can increasing the absorption of visible light. And also there are other many methods can improving the photocatalytic performance of titanium oxide. And here this table summarizes the four methods and the effects of the effects on the titanium dioxide. So it shows that the product produce hydrogen using TiO2 as a photocatalyst is a sustainable route for energy production, and this is the responsibility for us chemical engineers should take for sustainable development of our society. So next, let's do the conclusion. So in summary, hydrogen as a clean and new energy resource plays an important role of energy structure transition. Among the many current hydrogen production methods, using Nano TiO2 as a photocatalytic catalyst to split water and to generate hydrogen is a very promising method. TiO2 can be divided into three types according to the crystal structure, and that mechanism of the water splitting is discussed. Next, the two preparation methods, solver thermal alkalized and the soldier method of titanium dioxide are introduced in this report. And meanwhile, due to the low photocatalytic efficiency, for improving method involving the ion doping composite semiconductors and the dye sensitizations are introduced to improve the photocatalytic performance. And here are mainly three challenges, which is firstly, the low catalytic efficiency caused by wide energy gap and the low solar absorption rate of titanium dioxide. Secondly, the high cost of the production to be applied commercially. And thirdly, the lack of scalable system to produce hydrogen in an economic viable manner. And next, I will pass time to Xinyang.
And for the perspectives, here are many 3 points. The first is couple of different improving technicals like compound dye sensitization and ion doping. And the second is looking for cheap metal doping to replace the expensive PT. And the last is to adding perovskite to improve the photocatalytic performance of titanium dioxide. And we can firmly believe that the use of titanium dioxide photocatalytic to produce hydrogen will play an important role in the future. And that's our reference for the report. And thanks for watching. That's all.